Okay, this is another examples of Newton-Raphson. Okay, the solution of a non-linear equation by using Newton-Raphson method. Right, so let's see what is this is a guided question where they are guiding you. So by sketching the graph of y equals 2x and y equals to 3 cos x on the same coordinate axis, show that this equation has only one positive root between 0 and pi, only one root, and it lies between 0 and 1. So it means you need to verify, right? So let's sketching the graph. So okay, let's look at the graph. So y and the x-axis. So we have 1, 2, 3, right? 1, 2, 3. As you see that, I need to sketching the graph of y equals to 3 cos x, right? 3 cos x. It is better for you to sketching by using graph paper or a ruler, right? A ruler for accuracy. So -3. So as you know that the graph here, maximum will be 3, the minimum is -3 for 3 cos x. So then this is 0, and later on they have pi over 2 and pi, right? I just drawing up to pi, not 2 pi, because the interval is 0 up to pi, right? So during 0, it will be 3. During pi over 2, as you know that cos 90, cos pi over 2 is 0, right? So 3 times 0 is getting 0, and pi, you have -3, right? So the shape of the graph will be looking like this way, okay? So will be looking like this way. So a complete graph will be this, right? So we just want from 0 up to pi, right? And we also need to sketch the graph of y equals to 2x, right? Y equals to 2x, as this y equals to 2x is passing through 0, right? Passing through 0. So we can choose another point here to find the value here, right? So we can choose this to be pi over 2, right? 2 times pi over 2, you are getting 3.41 something, right? So it means that during x is 0, y is 0, right? Y is 0. So during pi over 2, we just need 2 points to sketch a graph, right? So 0, pi over 2. So we means that when x is pi over 2, right? When x is pi over 2, so what is the value of y? It will be 2 times with pi over 2, right? 2x. So 2x, so 2 times pi over 2, we have pi. Pi is approximately the value of 3.14, right? 3.142. So roughly, we know that during pi over 2, the graph will be 3.142. Let's say this is 4. But if you're using ruler, you can see exactly, right? So you just roughly sketch, okay, pi over 2. So somewhere around here, 3.142. So this point here. So if I sketch the graph, if I drawing this graph, it will intersect the graph, right? For this line, the name is y equals to 2x. And this graph is the y equals to 3 cos x, right? Exactly, the graph, this line intersecting the graph at this particular interval from 0 to pi is only intersect at one point, right? And the roots here, the intersecting point here will be shows the roots, okay? As during this point, the y value are the same, right? During this point, the y value are the same. So it means that 2x is equals to 3 cos x, right? 2x is equals to 3 cos x. Or we can say that 3 cos x is equals to 2x, right? These two values will be the same once they intersect, right? So means that if I bringing this go over to the left hand side, this will become an equation, right? So these two will be the same, means that you solve when they are the same, you minus, you're getting 0, right? So it means that the roots here, this is your roots, okay? The value of x that satisfied this equation, right? That satisfied this equation. So it means or the same, that the value of x such that the value of y are the same. The x you're putting here, you have the same y value. When you're putting the x here, you have the same value. So this is the roots, because after you minus, you're getting 0, right? So therefore, this will be the roots of this equation, right? Then it's only one positive roots, right? We have already show that has only one positive root. Why? Only have one intersection point. Only one intersection point, right? Only one intersection point in 0 up to pi, right? From 0 up to pi, there is only one intersection point. But how to further verify that n, it lies between 0 and 1? How to further verify that it lies between 0 and 1? So if we need to use the knowledge of, let's say I need to, do you remember the first example that I said you let fx to be 3 cos x minus 2x, right? You let this to be your fx and show there is a change of sign. I'm not sure it's between 0 and 1, right? I'm not sure it's between 0 and 1, as this is pi over 2 is greater than 1. I don't know this value is between 0 and 1. So how to further verify? Through the graph, I know there is an intersection point here. So there is a root, okay? There is a root within here, one root. But I'm not sure this value is between 0 and 1. Okay, how to verify? I have to using the test, right? The change of sign, the test here. So f0 and f1, right? I apply. So the concept. So we have 3 cos 0 minus 2 times 0. As you know that cos 0 is 1, so we give you 3, which is positive, right? It's a positive, or we say greater than 0. And f1 is 3 cos 1 minus with 2, right? So make sure your calculator is in radian mode, right? After I calculate, I'm getting 3 cos 1 minus with 2, right? 3 cos 1 minus with 2 in radian mode. So then you're pressing equal, you're getting a negative number, okay? Negative 0.38, which is negative. Negative. There is a change of sign, right? There is a change of sign, means from 0, at 0, positive, at 1, negative. This shows what? This shows that, therefore, 2x minus 3 cos x equals to 0 has a root lies between x equals to 0 and x equals to 1, right? We have verified by looking at the changing of sign. But through the graph, we just can know there is a intersection point. So it means that there is only one positive root. Can you see that this is positive, right? The x value is positive, so it's positive root. But we're not sure this is within 0 and 1. So what I'm doing this test here. So I know that now I have verified one positive, one negative, and I know that it will be within 0 and 1, right? So this is the verification. So we're very sure that there is a solution. The answer can be 0.1, 0.2, 0.5, 0.9, any value in within these two. So how to get that value? We need to use Newton-Raphson method. But this question, they're asking to use Newton-Raphson method with the first approximation 0.5. They have already decided for you what to choose. So it means that within this one, they're choosing your x1 as 0.5. Alright, let's see how to deal with this. How to find that particular roots, the value of x here, by using Newton-Raphson method. Alright, okay. Let's find the roots, right? So as first, we have to tell you the formula for Newton-Raphson. So which is xn minus with fxn divided by f prime xn. So as this is an equation that involving trigonometric equation, there is a function inside the equation which is trigonometric equation. So now for the first thing that you need to do is in your calculator, you change to radian mode, alright, radian mode. So before you're solving. So this is your, so as from the Newton-Raphson formula, you need the fx. So as I know that this is fx equals to 0, so I know my fx will be 2x minus with 3 cos x. Once I have the fx, I straight away find the first derivative as the iterative formula, the Newton-Raphson iterative formula needed. So we have to differentiate 2x, we get 2, differentiate cos x, differentiate cos x, we have negative sine x, right? So 2x, so 2. Differentiate cos x, we have positive 3 sine x. Because differentiate 2x, you're getting 2. Differentiate cos, you're getting negative sine. So you're getting positive 3 sine x here. So the iterative formula for this case here will be n plus 1 equals to xn minus with your fxn, 2x minus 3 cos x, your fx, over with your f prime x, 2 plus 3 sine x. So this is the very powerful iterative formula to getting that roots that we're not sure where it is. We just know it's between 0 and 1, right? So this question has suggested that we need to use the first approximation, your x1, as a first for 0.5 in getting the x2. So means we need to find the value of x2. x2 will be 0.5 minus with 2 times with 0.5 minus with 3 cos 0.5 over with 2 plus 3 sine 0.5. For this, we were getting the value of x2, right? And further, we were getting the value of x3, right? x3. Until when we stop? Until the x4, the approximation, the third approximation, the fourth approximation, until the two values, the consequent two value become the subsequent two value become remaining constant after round off to 3 decimal places. Means they remain the same, constant. So that is the roots for this equation. So let's see how to getting all these roots here by using the skill from calculator. Alright, okay, let's continue using this calculator. So I'm going to key in this into my calculator, the iterative formula here. So which is alphabet x, make sure in radian mode, alright, minus with negative with pressing this, and just key in exactly the same. So 2 alphabet x minus with 3 cos, right, alphabet x. So divided by 2 plus with 2 plus with 3 sine alphabet x, right? You see, x minus 2x minus 3 cos x over with 2 plus 3 sine x. So this is the iterative formula. So when we find x1, we're putting x1, we're getting the x2. When we're putting the x2, we're getting the x3 until the value remain constant, right? So okay, let's look at how to getting the x2, right? So pressing the button, calculate, calculate. So the first value that suggested by the question is 0.5. So we just key in 0.5, then press double equal 1 time, 2 time. So we're getting 0.97487. Wow, it's very far, right? So 0.97. So since they're asking us to giving 3 decimal places, so usually we will give extra 2 decimal places or 1. So for my lesson, I will giving extra 2. So 97487, right? So from here to here is a big change. So we have to continue. So now we are using x2, right? We are using x2 plug into the formula, the x2 to getting the x3. So the easiest way to do is to getting the value first. We just calculate, pressing the button, calculate answer, right? Calculate answer, then pressing 2 times equal, right? 1 equal and 1 more time. So again 0.91555, right? 91555. So you see it's changing, right? It's changing. So if you round off, you're getting 975. This one, if you round off, you're getting 916, which is changing, right? So we continue for x4, right? So easy, using this value, right? Using this value for x4. So you calculate answer, then 1 time equal, you see, you are using this value, right? you are insert this value. So now you're pressing another equal means that you substitute into, so you're getting 0.91486, right? 91486, which is still changing, because if you round off 91555, if you round off, you're getting 916, right? So okay, so if you round off this, you're getting 915, still changing. So we go for x5, so we just key in calculate answer, 1 time, 2 time, so we're getting 0.91486, right? 91486 after round off, right? So can you see that it's already constant, right? After round off, getting already constant. But if you round off, this is the same value, right? If you round off, you're getting 915, 0.915. So it means that it has reached a constant value. So we stop here, right? We stop. We never go for the 6th iteration. Okay, the 6th approximation. So means that the roots for this equation will be, by using calculator, we know that it will be 0.915. This is just helping us to avoid in substituting this for many times, all right, from calculator. Okay, let's see how to write in your step. Right, okay, let's continue by filling this value with the one that I get from the calculator, right? So your x2 here will be 0.97487 as the second approximation. And I'm going to find the third approximation. We substitute this into the iterative formula here to get the x3, x2, right? So it will be 0.97487 minus with 2 times 0.97487 minus with 3 cos 0.97487 blah blah, okay, 2 plus 3 sine 0.97487, right? So for the x3, the value will be, we are getting is 0.91555, 0.91555, and I will not showing the substitution anymore after the 4th approximation. I will just list down the value, right? Because understood that you already doing this, right? So means you are actually understanding how to getting the x2, the x3, and the x4. You have already shown by using the iterative formula. So the x4 I just list down, it will be 0.91486. And for x5 also 0.91486 here, right? So I have stopped here, right? I will stop here. Why I stopping here? Because this is already remain constant, right? It's already remain constant. So therefore, the solution for this problem will be 0.915, right? 0.915 is the roots for this equation here. All right. There is another way that I can teach you shortcut how to getting the roots, right? By using this calculator also. So you can get the answer directly by using this calculator. Very easy. Initially, you can straight away key in this, but because you need to use the Newton-Raphson formula, right? The method. So this is the method. So, but you can do your final check by using calculator. So you can key in the function 2 alphabet x minus with 3 cos alphabet x, alpha equals to 0. Alpha equal, solve here equals to 0. Key in exactly the equation here, right? This equation here. So then you shift calculate 2 times, 1 times, or 2 times also can. So you already directly get the answer. Okay, this is the answer, right? This is the answer. Very fast. Without doing iteration, I can straight away get the answer. So if you round off, you're getting 0.915, right? Okay, you see, you round off, you're getting 0.915. So this will be the solution for this problem here. So now you can see they have shown that the is one positive root and it lies between 0 and 1. Yes, it really lies between 0 and 1. 0.915 is between 0 and 1. So this is the powerful of Newton-Raphson method. So hope you understand.